Hello, everybody. My name is Maxwell Ogunfunwa. Today, I will be talking about multi-label classification in the world of machine learning, AI, data science, all that fun jazz. So I'll go ahead and talk about myself a little bit. Max the Dev is my code name. I never use it, but I would like to sometime, so here we are. I'm the owner of Meteor Analytics. I am a data scientist at Indiana Farm Bureau. I'm a self-taught programmer, and a fun fact is I studied psychology during my undergrad. So I'm like one of those weird people that happen to be here in this glorious time of data scientists. And so, I mean, if you guys are looking for an opportunity or a job in this area, don't let your perceived inability to program stop you. You guys are more than capable. If somebody from a psychology background can be here talking to you about multi-label classification in the world of data scientists. And so, an overview for my talk about multi-label classification. I'm going to say it over and over and over again because there's going to be other types of classifications I'll discuss just so that we can get a feel for it all. But I'm going to talk about why I chose this topic. I'm going to talk about supervised learning. I'm going to talk about classifiers. I'm going to talk about, you guessed it, multi-label classification versus other types of classifications. We're going to talk about a real-world example, which is basically using Netflix movie/TV show descriptions and being able to predict their genres and the multiple genres that are associated with that particular show. So, if it's a drama, an action, and an international movie, being able to actually classify those in a way that works in a real-world example. And so, without further ado, let's jump in. So, Maxwell, what do? I study machine learning and AI. And I always get this from people. They're like, when will AI take over the world? And I'm just like, oh gosh, how do I do this? And so I look at them really calmly and sternly and I say, you know what, it's already happened. And then I let them freak out for a little bit before I tell them, like, AI is still pretty dumb. It doesn't really understand or know very much. We can make it seem that way because we spoon feed it data and then we test it on the exact same data that we fed it. And so these classifiers are predicting all these magical things. And it looks really, really cool. But in due time, machine learning and AI will build these models that are actually able to understand our real world. So not just these dog or not dog classifiers or hot dog, not hot dog, our classic get started tutorials. But saying that AI is really dumb is really important because a lot of people get confused when they see things like models playing hide and seek and being able to actually create strategies that we could never teach them in order to, hunt each other during this game of hide and seek. And so you hear about these things like curiosity and attention and all these different aspects of being able to apply reinforcement learning. But those are still very isolated environments that these models are learning within. And it has nothing to do with our real world. So, just tell people that AI is dumb and they don't have anything to worry about. Their kids will have something to worry about. But us, hopefully, we won't see it. So, supervised learning. There's three factors that go into supervised learning. We have an object, we have a label, and then we have a classifier. An object is basically anything that we want to predict. So like this lab coat, if I wanted to create an image classifier that was like, hey, is that a lab coat or a t-shirt? I can create a classifier to do so. But before I can do that, I have to first tell my data set that this is a lab coat instead of actually a sweater or pants or some black Vans or socks or something to that extent. And so supervised learning is this concept of having an object, having a label, and then creating a statistical model that is able to accurately and confidently prescribe that label to this object. And that's kind of the world that we're going to lean in for this talk today. But there are other things besides supervised learning. We have reinforcement learning, unsupervised learning, and the list is kind of growing as time progresses. And so it's still really, really cool because we can do a lot of things with supervised learning. And I'll talk a little bit about our example today before I hop into the code. So our object, which is going to be what we're trying to predict off of, gather features from to understand, will be a Netflix film or TV show description. So Stranger Things, you have a description for it. Some girl busts out some government factory and starts running the world with some little kids all over the place, And then we have a label to say that there's action, there's drama, there's a whole bunch of I don't know, what's another one? It's not a crime show, but there's a cop, so maybe. So those are the labels that are associated with it, and we're going to actually create a classifier that does multi-label classification to predict all those categories instead of it's just a drama, or it's just an action, or it's just a really intense criminal TV show. And so, gosh, classifiers are really, really intense, especially for organizing data in our real world. For my day-to-day job, I spend most of my time building classifiers to predict business processes based on whatever data that comes in, whether that's text, images, phone calls, you name it. We can use those and classify that because we can then begin to automate. And so I always tell people, if you really want to start somewhere in machine learning, start looking at classifiers. And so the three major ones that I find really interesting and probably the most useful are going to be binary classification, multi-class classification, and then multi-label classification. Binary classification was the first one I spoke about, so is it a dog or it's not a dog? There's no other object in this world. There's only a dog and not a dog, and if it doesn't fit into that, it doesn't care, it's not a dog. And so binary classification has its uses, but it's very limited, as we can see, such as human, not human, hot dog, not hot dog, the classic 0, or 1. So keyword you want to make sure you see is the or, right? The or and then the not. And so then we go into multi-class classification, where we can now do things of saying it's a boy, or it's a girl, or it's a man, or it's a woman. Now there's multiple classes involved, which is a little bit harder to predict. It gets a little bit more complex, but it's very, very possible, and we're already doing it on large scales. I don't know if you guys keep up with China or anything, but they have taken like machine learning to the next level, and they do some pretty cool things. Like that infrastructure is quite beautiful. And also we have apple, orange, pear, mango. But the biggest thing to notice here is that we have multiple classes, and that or goes about all of them. And so we go into my talk today about multi-label classification, which I would say is the hardest and the more realistic option of classification, which is going to be action and drama and an international movie, or if it was ice cream, vanilla and strawberry and chocolate are my favorites. Being able to actually predict all three of those in comparison to our binary or multi-class option is quite difficult, because now I have to teach a classifier that this lab coat is not just a lab coat, it's an IndyPy lab coat. And that this lab coat isn't just an IndyPy lab coat, it has Python on it. And for a model to be able to do this with accuracy not only includes us having tons of data that can show that model that this object is indeed what I'm telling you it is, but also the fact that it's also able to do so in a way that it can do so repeatedly. And so let's go ahead and move on. So just for our visual learners, just to make sure that this idea is ingrained before I jump into a few more examples, we have our multi-class where you see we have columns 0, 1, 2 to 4. And the only column that's selected on row 0 is going to be 1, and that's going to be a multi-class. So there's only one class that's selected. So this would be our boy in comparison to girl, man, and woman. And in our multi-label, we see that there are multiple classes in a single row that are selected, which is going to be our example today. Can we do that in text? And so the coolest thing that I've seen in modern times is that we're actually able to do this in computer vision rather easily. As humans, we perceive with our eyes. That's what we kind of do. We look very often. We have glasses to help us look even better. We have telescopes to help us look far, and everything else in between. So one really cool thing that happens in the real world is that you could actually run a YOLO classifier from your phone with your camera in the real world. And you can do these multi-classification type classifications on a street. And so what we're seeing here is that we're classifying people, we're classifying cars, traffic lights. I think that even says bus in the back, truck. It's classifying a truck. And this is a model that is built, you can run on your phone right now if you wanted to, on this whole room. And that's really fascinating because it's very realistic. We can now start to discern what a summary of an image or a video would be like. And it's just, really useful and cool. And businesses, governments, agencies, anybody could begin to use this. But the real question is, can you do this with text? And so what we see here is another example of it being done with images. We have Clash of Titans, and we tell it that it is a genre of action, adventure, and fantasy, but it's learned other things in its data set. So below you'll see the prediction where it says action, adventure, drama, fantasy, horror, sci-fi, thriller, and you can kind of see maybe how it's getting all that. The dark colors, the guy looking like he's screaming out to the sky like, curse you, and then a sword in his hand. And then we have this couple over here in a bed, and then clothing and pillows, and you can see how it got, comedy, drama, romance. She's smiling. And so with images, we're definitely able to do this. But the question, once again, is, can we do it with text? And is it possible? So for my short answer, I say it depends. It depends on tons of factors, and your data set's going to be the biggest one. Is your data set vast enough to actually produce enough labels for a particular set of words? In words, there's less features to actually be drawn from in comparison to pixels, because with pixels, you actually have three spectrums, the RGB, you have the red, the green, and the blues that you can now classify as particular features. With text, you just have words that you're supposed to somehow generate context with, which with n-grams is a little easy, but I digress. The long answer is yes, but there's a lot of effort that kind of has to go in, and that's what I'm going to show you guys today. So let's go ahead and jump in to my Jupyter notebook. Can I make this bigger? The question. Yes. Okay, so as you can see, it takes me tons of libraries and frameworks to do this, but the main one I use is going to be sklearn, and I was pulling in tons of different ways to kind of see how I can do this. It's not that important, but from a framework standpoint, I would say the Natural Language Toolkit, sklearn, pandas, numpy are going to be the majority of our tools that we use, and then for some visualization, we use Seaborn and Matplotlib. So my first task is going to be pulling in my data set, which I got off of Kaggle. I'll show you guys a link once I get done with my talk. And so what does our data set look like? Basically, it's going to tell us if it's a movie or TV show, a title. We have a director, our cast, country, date added, release date. All that stuff I don't care about for my example. Only things I care about are going to be the genres, which is called listed in, and the description of that movie. And so from there, after I pull in my data set, I can close this. Maybe. Yes. So before I jump into a data set, the first thing I always do is try to explore it. I also want to understand it and be able to see what is missing, what is not missing, and how I can clean it. And so the first thing I'll always do is check for any null values in that data set so that I can clean them out. So I check in description and listed in, which is our genre category, and I get false back, which is very good, which allows me to say, okay, Max, it's time to pre-process this data. Let's get it moving. Well, the first thing I want to know before I start pre-processing is how many labels am I working with? So I want to find out how many unique genres exist in my data set. So as you can see, I have a list right here, children and family movies, thrillers, docu-series, TV thrillers, British TV shows, classic cult TV, goes on, but there's 42 in total. Another thing that I like to do and I recommend as being a must is visualizing your data set. And so right now I visualize all of my labels involved, and you're going to notice that there is a huge discrepancy between international movies, I think it is, and dramas. And so Netflix has a very favorite type of series they like to put out. They like to cater to their international demographic and also the dramas. The only problem with this is it kind of skews my data set. And that makes more work that has to be put in order to actually get accurate readings. And so after we get through of understanding what's in our data set, you want to pre-process what you'll be working with, which is going to be that description of the movie or TV show. And so what I do is I pre-process. I make everything lowercase to make it easier to differentiate between. I remove punctuation. I remove common words. I remove rare words. I remove stop words like the, and, is, anything that might be extra noise in my data to get rid of it as much as possible. And so I run that on there, and then I create a new category or a column, pre-process. And so you can see that there is pre-processing being done. I remove the word before. It's not as important as the word planning or awesome. I remove for his, and we get grandfather, which is right here. And so the pre-processing has been done on our entire data set, which is really nice. And so then I want to look at, okay, what type of words are actually in here that I can use to leverage? And so once we begin, we see that, to is used quite frequently. We see that come, back, and show are used quite frequently. And one thing that you really just want to make sure is that your distribution isn't skewed. You want to make sure that there aren't very many words that are kind of being used in one specific category, which would bias your classifier. And so we move on. My next step would be to create an encoder from our target variable. So for those 42 categories or genres that we have, I create a multi-label classifier. And so each category, each genre gets its own section inside of my encoder. And then we have, a 0 or a 1 if that classifier is, or if that genre is there. So here we have children and family movies, and we also have comedies. And so after all this is done, I've encoded, I've gotten all of my data correct and ready to be processed, we can really start, building our model and kind of getting ready to do everything. So we create our train and our test set. So that I can start training my model and then or my classifier, and then I can have a way to validate it. So the first step is always going to be some form of vectorization. The models actually don't read English or any language, they read numbers. And so you have to be able to convert those words into vectors, which is what TF-IDF allows you to do, which is short for term frequency, inverse document frequency. Allows you to work with words and process those into numbers. It's one method you can use, not the only one, but it's one that I decided upon. I then convert all of my words, and then here was kind of where the fun begins. And these 3 lines of code is how I build my classifier. I choose logistical regression as my origin classifier. I then use a method that is still heavily under research called one versus rest classifiers. It makes a classifier for each genre, and then is able to predict whether that genre is present within that description. And then I begin my training. And it takes a couple of seconds, really, to train over our data set, which unfortunately is about 6,000 rows long, which hinders accuracy a ton, but is also okay because it still allows us to see the process and that it still works as long as your data set's huge. And so what I do then is once I've created my classifier, I then take in my test set. So I can now use that to make a prediction on my test set. And so what we got for our F1 score, which is basically precision and recall, being able to see how precise my classifier was and how much of that it recalled of what I've taught it, we actually get a 14%, which is super low. But once again, these things are super dumb, especially with very small amounts of data. You can't really expect high levels of accuracy if it was only able to see 10 examples of, let's say, cult movies and TV shows. However, I will show you later that we can increase this if we do increase the amount of data rows we have available. So what I do next is let's have a little bit of fun. Let's try some random things it hasn't seen. So I'll create a function to clean my text. I'll create another function to remove my stop words, and then a function to to predict the genre of a specific description of a movie show or movie or TV show I might be using. So I pick some random ones, a random sample, and I get Justice in the City, and it predicts that it's an international TV show, but it's actually an international TV show and a TV drama. I also use Lost and Found Music Studios. It says that it's a drama, but it's a kids' TV show, a TV comedy, drama. And so it's able to actually put these things together and start saying, I'm seeing some type of patterns, but essentially it's more data. And so I found a bigger data set, which wasn't Netflix, but it's still fine. And it came from Carnegie Mellon. They had about 45,000 rows, which is much more than Netflix. And I was actually able to do the same exact process and get an accuracy score of right around 40%. And so that tells me that as long as I have more labels to show my model so that it's not underfitted or overfitted, it'll be able to better understand this kind of real-world example of describing, a genre for a particular movie or TV show. And so, with that being said, and me rambling for way too long, Thank you so much for listening. My name is Maxwell Ogunfunwa. You can find me on LinkedIn. You can email me at maxwell@meteoranalytics, and hopefully you come to chat with me whenever we are done here. This is the data set at Kaggle if you want to find it, and then that video I showed you of the street and all the classifications was a YOLO model. It is really cool. You can pull it up on your phone and leverage it and use it right now when you go outside. It might be too dark, but it works.
That's awesome. Let's give him a big round of applause. Is your Jupyter notebook going to be available someplace?
I can send that.
Yeah, if you can put it in
Josh.
GitHub or something like that. And
Okay, cool.
We'll send out a link to it because I think
Yeah.
people would love to maybe play with the code.
Sweet, yeah, definitely.
Are there any other questions for Maxwell? Come back here. I'm going to give you the mic because there's people on the live stream who would love to hear your question.
Hi, Max. How is multi-label classification different from just, in your case, training 42 binary classifiers?
Yeah, so you could essentially do that. I just think it's a little bit more overhead work, right? Like I would now need to train separately those 42 classifiers in comparison to using this one versus rest methodology of being able to kind of take all those classifiers and put them into one, and I only train once. And so it's definitely an option you can take. Your sample size is going to be significantly smaller though, because you only have your classifier which has dramas, you only have your classifier which has international TV shows, and then you're telling it to predict on things that it may have never seen before. So if there's similarities in that classifier that aren't necessarily real, but they are similar, it can make mistakes a little bit easier in comparison to seeing everything. I hope that answers your question.
Hi, I'd be curious to compare your success rate to humans reading the descriptions and coming up with, because
Great question.
What it really comes down to is how well the descriptions are written to begin with as well.
Exactly, and so this is why I think the human-in-the-loop methodology of applying machine learning is probably the best way to go about it, and the way I recommend clients go about building this. You need to build your machine learning model in a way that it is prepared to accept terms that you have created that it has already been trained upon, right? So I wouldn't want to use words that are too distinct or rare, because it's then going to cause issues in my classifier. So me as a human, I want to say, okay, my model has already learned kind of this word for action and this word for drama. I want to make sure I consistently use that, so I help this model as much as possible understand a real world scenario. That's why, once again, they're dumb, because if it's never seen this word and this genre associated, even though me as a human, I know this is a crime movie, it won't be able to predict such things.